How does Grover's algorithm find multiple targets? Imagine searching through a huge library for several specific books. Doing this one by one would take ages, right? Now, picture having a special tool that can find all those books faster than any traditional method. That's what Grover's algorithm does for quantum computers when hunting for multiple solutions. Grover's algorithm is a method used in quantum computing to find one or more solutions within an unsorted database. It works much faster than classical search methods, especially when the database is very large. When there are multiple targets, the algorithm adjusts to find any of them efficiently. Instead of just looking for one answer, it can find any of the multiple solutions with high probability. The process begins by creating a quantum state that represents all possible entries in the database at once. This is called a uniform superposition. Think of it as having all the books in the library open at the same time. Then, an oracle function is used to mark the target states. It does this by flipping their phase, which is like putting a special sticker on the books you are searching for. This marking doesn't tell you what the books are, just that they are targets. Next, the algorithm applies a process called the Grover diffusion operator. This step amplifies the chances of measuring the marked states. It does this by reflecting the quantum state about the average amplitude, which increases the probability of finding a target when you look at the system. When multiple targets are present, the quantum state can be thought of as a mix of two parts, the marked target states and the non-target states. The key idea is that the algorithm rotates the quantum state within this two-part space toward the target states. The more it rotates, the higher the chance you'll measure a target. The number of rotations, or iterations, depends on how many targets there are compared to the total number of entries. If there are m targets and n total entries, the optimal number of iterations is roughly proportional to pi divided by 4 times the square root of m divided by n. This means fewer steps are needed when there are multiple targets, compared to just one. It's very important to stop the process at just the right moment. If you go too far, the probability of measuring a target can actually decrease because of the oscillating nature of the amplitude amplification. So, timing is everything to get the best chance of success. In real-world applications, this approach can be used to find multiple matching entries in large databases or solve problems where several solutions are acceptable. It offers a quadratic speedup over classical methods, making it a powerful tool in quantum information theory and quantum computing. In short, Grover's algorithm finds multiple targets by marking all of them at once with the oracle, then repeatedly amplifying their combined probability through carefully timed operations. This process boosts the chances of measuring any one of the solutions, making quantum searches much faster than traditional ones.